Now we have all the core language. So in principle, any computation that is possible, there is a way that theoretically we could do it using just the things that we have. Whether that's possible in practice, that's another story. So now in the second part of this course outline, now we're gonna be putting the language in use. And the first we're gonna be processing some real world data, because Python makes it so very easy, and we have all kinds of real world data available in this standard JSON data format, and an example JSON file, the database, very simple, of the countries of the world that originally, so I generated this from the Wolfram Mathematica. So just taking just a couple of fields just to work as an example data. So JSON as a structured data representation, JavaScript object notation, but by amazing happy coincidence, the square bracket and the curly braces, so list and a dictionary, happen to mean the same thing in both languages. So the JSON file basically is a JavaScript or a Python data structure, but the JSON, this is not gonna be executed as Python, because somebody might put some nasty malicious code in there to be executed in your computer. So then the JSON file, when it's read through the proper library that never executes anything, even if somebody sticks in some executable in there, then you can read the JSON files anywhere, and then they cannot in principle exist. So then of course the JSON files might contain data that is corrupt, but that's a spirit of our times. Any data eventually becomes a command to somebody. But so the countries database, so here we have a list of countries, and then whatever data you have, you can always represent it as a dictionary. You have some kind of a data fields that have names. So then the data fields have values, and well, we can always encode anything to a string. JSON would allow numerical data types also be used, but this way, so we know that the real world data is sometimes messy, so we have to clean it up a little. So extract here the actual number, and sometimes the real world data is missing and corrupted, so we have to find ways to deal with that. Notice that these nestings can go in arbitrary deep, so a dictionary, so here the key natural hazards is associated to a list, so this nesting can be arbitrary deep. Now here it's a good point to realize, what if a country has only one natural hazard? Some people succumb to the false economy, they make this value to be just a single string, but now somebody who reads through this data now has to handle one hazard and many hazards different way, but using a list, even when it's just a list of one element, and then more importantly it can be a list of non-elements if there are no natural hazard. Sometimes people wonder, why would you make an empty list? But the empty list is the correct answer from any function that returns the list of the things, and nothing that you exist satisfies the condition. So Afghanistan recognizes the natural hazards of a drought, earthquake, and flood. So this way, in principle, any data can be encoded. So we have a list of things, and each one is a dictionary of fields. So let's reading through our Python code, see how to read through a JSON file. And this becomes very easy, so this is so important that it is there in the standard library, the JSON module. And just like we open the file, so then we are opening a file in here, opening a text file, so we're opening our country's JSON file, and JSON, it has a function load, so then give it a sequence of lines, and this JSON reads it through and doesn't execute anything that is executable, enforces that all the data is proper harmless types like strings and similar, and whatever data object, so here the list of dictionaries the file describes, so this creates and returns that object, well, perfect copy of one, but is as good as for us as the original, so this one actually exists inside our computer. So this one is now gonna be the list of the countries. So we can ask, so how many countries So here the output, this Wolfram database recognized 240 separate countries. And then, so what we're gonna be doing is that we're gonna be calculating the population of every condition, every continent, and then we're gonna sort the continents in descending order of population. And then we're gonna be looping through the countries and their hazards and tally up, build up a dictionary of counters again, how many countries is each particular hazard encountered. So first is calculate the population of every continent. So we build up a dictionary. So in this problem we know in principle what continents exist, but this dictionary, this is so flexible, so you don't need to know what's gonna be coming. So whatever's gonna be coming, you're gonna be ready for it. So you can add whatever you want as the dictionary keys. So maintain the Earth's total population and the dictionary of continental populations. And this countries is a list of data objects, so we can loop through those with the perfectly ordinary for loop. And knowing that country is a dictionary, then we just use the dictionary square brackets to access the individual data fields. So for each country we find out the continent, the population. So remember, population was given with the units attached to it. Like Wolfram Mathematica doesn't even care. Like it just handles this like an ordinary number, but that's that environment. One day maybe I'll get to teach that, but that will be a very strange day. Okay, so we're now extracting the population. So this is how you remember the split method. Take a string and split it into words. So here we just use a space as a separator. Take the first result of the splitting and convert it into an integer. So the split, all we care about is the first word that in all of these is gonna be the integer population. And then, so once we know what continent that country is in, so then we can update the counter. So the new value of the population counter in the continental pops dictionary is its previous value, or again, so the default 0 if this is the first time we encounter this continent in our travels, and then the new value is the old value plus the population, and then the Earth's total population increases by the same amount. Now, here we have a couple of interesting one function decorator, the sorted. Normally sorted means sort in ascending order, so but there was the reverse keyword option, you can sort in descending order. But the next one, the key function, there is an interesting and very useful thing in here. So if you sort the keys without giving a sorting criteria, so this would now be sorting the names of the continents in the dictionary order. But using a different key function, like in iTunes or something, there is like that sort as if it were something else. So sort as whatever they call it. So this key function, which here is given as a one-liner. So this is a whole new language thing. We're getting a sneak peek. Lambda creates a function object that takes this parameter. So we make a one parameter, but could be several, and a one-liner expression. So use as when you're sorting a continent, use its population as the sorting criteria. So then we get the continents sorted. So Asia has the highest population, so almost 4.5 billion at the time, and Africa was the next, only 1.1 now, so whatever these are now. So Oceania looks like, yeah, that's the rarely heard of this, but that's where they are. So that's already 7.2 billion, so whatever that one happens to be now. A couple of years ago I wrote this example. So this sorting with respect to the custom sorting criteria, we're gonna be encountering this in future examples, and will be handy in a couple of labs. So then we can print out the total population. And then again, we're counting things, so we make a counter dictionary. Again, we don't need to know what's gonna be coming, so the dictionary is ready for anything that's gonna be coming when if there is some unknown hazards discovered. So running this again, this is just as ready. So loop through the countries individually, and then each country is a dictionary of fields, so ask the value of the data field natural hazards. And then so it's a list of some kind, and notice we didn't succumb to the siren song of the false economy that where we use the list or a none value, that the singleton list and empty lists are perfectly legal and they're the correct thing to do when the situation calls it. So then we can just loop through the individual hazards, and if there is one hazard, so then the loop runs once, so what, and especially if the hazards list is empty, so then the loop correctly does nothing at all. So the same principle again, ask the counting dictionary how many times we seen the hazard, 0 as a default if the first time, add 1 to it, and that's gonna be the new number of times. Now sorting the hazard table, again if you don't give a custom comparison key, you get your hazards in the alphabetical order, but here we use as a sorting key, so a function that takes the hazard and then converts it to the frequency in the hazard table. So we're gonna end up with the hazard sorted in descending order because reverse equals true. So a flood 72 and that's it. So then because we didn't give a secondary criteria, so these maintain their original order, whatever that was. So this way, notice we can be poor man's data scientist. So this kind of serious stuff, the people would be using NumPy and SciPy, but just by reading structured data from a JSON file, we have ways to handle with the structures in a couple of lines of Python. So we can do this kind of poor man's data science.